Yay, that's my screen. Okay, hang on, now I'm going to start a timer because this is, I've only practiced this once and it did not come in 15 minutes. But we will have a go and see if we can make this work. So I'm a installation and visual artist, so I tend to do a mix of making big structural things with lights, a bit like the Cosmo thing we saw earlier, but also doing projected visuals and interactive installations, and also some live visuals, though I'm not a live coder. I'm going to prefix that with. So the paper goes into more the background of why I wrote Flitter and where it came from. So I thought maybe a more useful thing to do here today would be to write a Flitter program in front of you. Remember I said I wasn't a live coder, so I'm not really going to write it. I'm going to show you the steps of writing it. I actually wrote it yesterday on the train up. I was just toying with some ideas, and I wanted to go through the process of designing those visuals, because I was hoping it would show you both how I work and why I designed Flitter the way I did, I suppose. So yeah, maybe I'll just jump straight into it. So this is probably the simplest Flitter program you can write. And Flitter is basically a declarative language for describing visuals. So this is a description of what I want to do. So it's a description that says, I want a window and I want it to be that big. The exclamation mark means this is a node in a tree. So Flitter, you build a tree of nodes. And then each node has some attributes. This one has an attribute that says how big it is. So that's kind of the simplest Flitter program. It doesn't do anything really useful, though. So to do something useful, I need to put something inside the window. So I do that by putting something inside that node. And in this case, I'm going to put a 3D canvas inside it. So immediately you'll notice Flitter uses indentation. So you may, if you're a programmer, you probably have opinions on using indentation-based languages. I'm a big fan of indentation, so this is how I designed Flitter. You'll have to just go with me on that. There's obviously nothing interesting in that yet, so I'm going to put some more things inside. I'm going to put a box inside my 3D canvas. There are 3 reasons why you don't immediately see a box. One is that it's very small. In fact, the default camera means this box is exactly 1 pixel across. So I'm going to make it bigger, and I do that by wrapping it in a transform that scales it up. So the reason I'm going through these steps is to show you this is actually how I tend to write Flitter programs. So I tend to sort of indent things and wrap them in other stuff. I tend to sort of work outwards. So I start with the box and then go, well, the box is too small, I need to make it bigger. The box is also, the second reason you can't see it is the box is too black. So I'm going to wrap it in a material node that makes it white instead. And then the third reason you can't see it is because there is no light. So I'm going to add a light into the scene. And now we have an actual Flitter program you can see. This is, in fact, a running Flitter program. I decided to eat my own dog food, and all of my slides are running Flitter programs. So in fact, what's omitted from the program here is if I do this, you can see that I've chopped off a little bit of the program. That little bit of the program I've chopped off is the bit which is writing the text on top of the image to show the program that it's running. Does that make sense? So you don't get that for free. I had to write code to show you the code. And I can also click this to hide the overlay so you can see. It's not very interesting at the moment because the light and the camera are both pointing down the z-axis, so we're just seeing the top of a box. The box will be more apparent if I rotated it slightly. So I'm going to add a little rotation into transform that just twists the box around so you can see, oh yes, no, it definitely is a box, not a rectangle. More interesting than this, of course, would be if the box was moving. And the way I do that in Flitter is basically saying, well, I'm going to just keep varying this rotation. So I can do that by using time. So this is a bit like, Flitter is basically a functional language with functions over time. So that was covered a little bit earlier. It does this in a very stupid way. I basically run the program 60 times a second, generating a new configuration, throwing the configuration over the wall to a renderer, and the renderer puts something on screen. And it just keeps doing that. Draw thing, draw thing, draw thing. I designed it deliberately to be as noddy as possible. Okay, so it's kind of doing something interesting now. But I didn't really want to work with boxes. So on the train, I was thinking of interesting shapes I could work with. And I decided to work with the Menga sponge. Am I saying that right? Does anyone know these? Has anyone heard of a Menga sponge before? Wikipedia wouldn't tell me how to pronounce it. It's a recursive structure where you keep taking a box and dividing it into 27 smaller boxes, and then pulling some out and throwing them away, and then you take the boxes that are left and you divide those up again. That's roughly the idea. Oh, no, I meant to talk about lights. Oh my God, sorry. No, you know what, I'm going to skip on from that. It's a waste of time. So, this is the code for a sponge. So Flitter is a functional language, so I can just describe the sponge as a function. If you're a programmer, then you can probably make sense of that. If you're not a programmer, it's okay, it doesn't matter particularly. If you are a programmer, useful things to know here are that I am a very lazy programmer. So Flitter has syntactic sugar allowing me to nest 3 loops inside each other in one line. The great thing about designing your own programming language is being able to just cheat. You just think, you know what, it'd be really great if I could just do that thing, and then you just do it. Anyway, so this describes the sponge, and now you can sort of see this is an order 1 Menga sponge, so you can see the bits we've chopped out of it. This is an order 2 Menga sponge, where we recurse in again, start chopping more pieces out. A 3 and a 4. And when we get to 4, there's now 160,000 tiny cubes in this. And you start to see the limitations of how stupid my system is, in that now it's going a bit too slow. This is like 15 frames a second. In a way, I'm kind of impressed it can do this at all. So we're not going to do that. We're going to go back to a 3-order sponge instead. Okay, it'd be more obvious that this is made up of smaller cubes if I made the box a little bit smaller. So I'm going to change the box in the function at the top there. If I hit the right button. So the box is a little bit smaller, and now you should be able to see that these are all individual cubes. That's kind of more apparent. I don't really like the fact that I've changed the box in the function. What would be neater is if the function, you could tell it what to draw at each point. So, this being a functional language, we can just change the function to take a node as an argument, and then because nodes are just another value in Flitter, I can pass the box in as an argument to the function. So you can sort of see that at the bottom. So same effect, but now I'm passing in a box. Okay, so I've tested my sponge function, so I'm going to do what any good programmer does, and I'm going to stick that in a module and never look at it again. So now I can focus on the rest of the code. And it turns out this thing about passing a node into a function, it was such a useful thing to do in Flitter that I, again, cheated and built my own syntactic sugar for it. So this is another way of saying the same thing. This takes the box, passes the box into the function, and then also adds some other arguments to the function, in this case, how deep to recurse. But this allows me to now make the box a bit more interesting. So now I can more easily change what I'm pushing inside this thing. So Flitter also contains this thing called constructive solid geometry. Anyone know of this? It's where you can take solid forms and you can mash them together or carve them out of each other to create more interesting forms. It uses the manifold engine for doing this. So in here, what I'm doing is I'm intersecting a box and a sphere, and I'm kind of putting the box and sphere together in the same space and cutting away the pieces that don't overlap between them. And the result is you get something that looks like a die, dice, as in, how dice have got circular faces and then chamfered corners. That's what we get. You can't see that because they're so small. So let's go to a lower order sponge so you can see. So now you should be able to see that this is actually made up of dice shapes. So this is really kind of neat. We can keep pushing this constructive solid geometry stuff through Flitter. So now I'm taking the whole thing and I'm unioning all those dice together into one model, and then I'm intersecting that with a bigger sphere to carve away the bits that I don't want. And you get something that looks a bit more interesting. I should maybe explain as I go along here that I tend to create visuals which are themselves sort of sculptural artworks. That's kind of the things that interest me, is making sculptural forms. If I zoom the camera in a bit more here, you can see properly what this looks like. So there we are. This is kind of, now we're starting to get towards something that feels kind of interesting to me. How do I have time? Yep. But it's a bit flat and boring still. So I'm going to start playing with some other features. So the first thing I'm going to do is I'm going to make each of the pieces slightly shiny, just because that feels like slightly more interesting somehow. What would be even more interesting would be making some more dramatic lighting. This is very boring lighting. So I'm going to change the lighting as well. So I've turned down the main light and put a really bright red light right in the middle of this thing. So the red light, which you can see down the bottom there, is characterized by having a position. So it makes it a point light. Instead of having a direction, it has a place. Some other cheats here. 20K literally means 20,000. Why not? If it's your own language, why not? What a useful thing to be able to do to say 20K instead of 20,000. It has to be that bright because point lights attenuate over distance. So you have to have a big number because the light fades away as it travels through space. Okay, so this is looking more dramatic now. The light you'll see doesn't come from anywhere. Lights in most 3D systems are virtual things. Like you say there's a light there, but there's nothing actually there. You just get the light coming from it. So it'd probably look more realistic if we actually added some object there. So I'm going to add a bright red sphere in the middle, so now it looks like there's glows coming from something. And this sphere in the middle has some emissive lighting, which means it glows instead of just instead of things shining on it, it emits light out of it. So I'm starting to piece this together now. It's looking a bit more interesting, but there's still something really flat about it. And that's because the 3D engine, in most 3D engines, I don't know if anyone's only done a 3D programming before, they do all the calculations in what we call a high dynamic range. So they're calculating lights that are too bright to display on screen. And then what you usually do is the final stage is you compress that range down into a shape that fits on the colors that the screen can do. And we call that tone mapping. And tone mapping is something which you do on the whole image. It's not something you do to a particular piece of it. You say, the whole image, I want to tone map that. So in Flitter, I would do that by jamming the tone map in right at the top. So now you can see that this structural approach that I'm trying to achieve here, that I say the canvas is inside the tone map filter, which is inside the window. And that's kind of why I designed the language this way, so that I could look at it and see how all these things plug together. So now this looks a bit more realistic. You can see there's a nice orange glow to the red light. I'm using what's called the ACES filmic tone map, if anyone knows these things. That's a particular one that's designed to look like film, basically like as in acetate film. And that tends to, the colors change when they get really bright. So that's why the red becomes sort of more orangey. So the other thing, that this is still quite crisp and clean. What I wanted is, usually when you see bright things, they have a little bit of a glow around the edges of them. So we call that bloom. So I can add a bloom filter. And again, you can see the order that things are being applied just from the structure of how the code's written. So the canvas, we draw the canvas with all the 3D stuff in it. Then we apply the bloom filter. Then we apply the tone mapping. And then we put it in a window. And that you should just kind of see there's a bit of a blur around the light in the middle now. What would be more interesting is the light was doing something now. It's kind of a bit dull at the moment. So I can add some more animation in here to make the light actually do something. So I'm calculating an impulse curve, a wave, and then I'm using that to change the size of the sphere and the brightness of the light. So now I think it's got more of a menacing feel to it now, which is what I was really going for. Something that feels sort of threatening, like it might explode, or, I don't know, a Borg cube of some kind. And then the final step, I think, really, if you want it to, the proper bling, I suppose, is to add the J.J. Abrams filter, and add some lens flare to it. So lens flare is just another filter that I can stick into this chain. And you should be able to see, there you go, come on. Eh? So that's my finished little visual artifact. And what I want to say here, I guess, is that I wanted to show you kind of the things I do and then say why, I suppose, which was, yeah, I'm doing okay, almost there. Which is that, again, I always wanted to create things that feel like sculptural forms, like you might make it. And when I'm doing live visuals, I'll actually be modifying these things live I actually use MIDI controllers, so I use knobs and buttons because I don't like tapping keyboards while I'm performing. And making things spin and change shape and change color and move, but they're always sculptural forms. So I wanted something that felt like a modeling language, or like a modeling system, like, I suppose, Blender, if anyone's used that. Something that felt like that you can build, or like a games engine, something that allows you to build worlds, I suppose, that can tell a story. But something that I could write code with, and something where I could write only small pieces of code. So this thing is, even if I include the function as well that I've hidden, this is about 30 lines of code. And what I was finding was that I tried doing this sort of stuff in like games engines, and there was so much code you have to write to do anything interesting that I gave up. I figured if I'm going to write that much code, I'm just going to write my own engine. And then the things I make in it can be simple. Yeah. Questions?
All right, so we have some time for questions. And on the live stream, yeah, we had a question about what programming language this was. And yes, it's been answered that it is Flitter. So this is Jonathan's own language.
Yes, so it's my own programming language. It is, so the engine is actually written about half in Python and half in Cython, which is a compiled version of Python. And it's all open source. You can find it on GitHub. I know we're not talking to GitHub anymore. I will change that. And it's almost entirely documented, amazingly. So even though I only wrote this and I am, to date, the only extant user of this thing, I actually documented it. So you can learn how to write Flitter, should you choose, which you probably won't.
Amazing, thank you. So now we have some questions. Start over here.
Cool, thank you very much. That was really cool. I always find it interesting when people are designing their own languages, you learn like what they care about by what they make easy. Is there anything that you deliberately made harder for yourself or any other users of Flitter?
You know, that's a great question, because yes, there are things in this which are deliberately hard to do. So it's pure functional language. It's almost completely stateless, which means it's very hard to do things that progress. And I mean, there's lots of things when you're writing programs, you just assume that, you change a variable and the variable is still there a moment later. It's the same value. You can't do that in Flitter. None of that exists. So a lot of things are actually a great deal more complicated to describe. But it kind of suits the way I like making things. And there is, to a degree, I find value in creating a box for myself that I can innovate within. So I kind of like that it's not a proper programming language. I quite like that it's a little box that I'm stuck in and I have to think of okay, what can I do instead? But yeah, that is a good question.
And we have time for another question. We come here. Let's come into the middle here. Thank you.
First of all, thank you. It's like very interesting. I have like a computer vision and graphics background, so like these animations are always like fascinating for me. You mentioned first of all that it's like half in Python. So do you have an estimation of like how much is this like rendering speed? Because I see that like the language is quite compact, but of course like we are stuck in this like very let's say nasty languages like C++ for like graphics engines that you also mentioned because of their like speed mostly. That's like first question. And second follow-up is that like the light source I was interested, because not in the inside but the point light that reflects the white light as the object turns. So is it possible to also manipulate this light source and then perhaps also add an additional, let's say, sphere on the back of this one and manipulate to shadow falling on the like other object?
Okay, there's a lot of questions there, but I'm trying to unpack them. Hang on. So the first thing was, yeah, speed. Yeah, speed is one of the constraints of the box. As you saw when I went up to 160,000 cubes, the whole thing just falls apart. It's like it's like I say, half of it is written in Python. I didn't write it really to be fast. I wrote it to be interesting. And I mean interesting to me. I mean, it may be interesting to anyone else. But I kind of there was a comment earlier about making yourself, Paul, wasn't it? About making yourself part of the artwork. To me, it's art all the way down. Like the writing of the engine was also part of my practice. Like that's half the fun, is making the engine. So I make it in deliberately idiosyncratic ways. So yeah, it's not fast enough. The bits which need to be fast are the bits I put in Python, so that compiles straight to C, and they're pretty good. I mean, like I say, it's not bad. It amazingly works with 160,000 cubes. And given the amount of work it's doing, because it basically builds the tree, then throws the tree over to the renderer, and then the renderer walks the whole tree and then draws something. This is an insanely inefficient way to do a graphics engine, but it was fun. Then the other question was about light sources, wasn't it? Yeah. So yes, obviously all the light sources can be animated themselves. You can just change the parameters. You can turn light sources on and off. Much of the work I do actually involves creating a sculpture object and then animating the lights that move through and around it, because that's kind of exciting, fun thing to do. I did an entire live set a little while ago where all the objects were gold bars. And gold is like metal. Metal has no color. This is the interesting thing. Metal's all in the reflections. So you can't really see anything unless you have light sources. So almost all the work was actually in animating the light and trying to find ways for the light to glint off the gold in interesting patterns. So yeah, I do a lot playing with light. You can have like 50, 60 lights spinning around without it really being a performance issue.
Right. Amazing. Thank you so much.
Yeah.
We probably have time for one more question. Yeah, here we go.
Okay. Hello. I love real-time visuals as well, so it looks really exciting and interesting. I just wanted to ask, you mentioned manifold engine, and that made me think, what is the type of surfacing? Is it polygons or is it signed distance functions? And secondly, because does your system, what is the setup for feedback, or what kind of ways can you do feedback, or if any?
So it's mesh based. It's polygons. So it's using manifold engine to directly do operations on polygon meshes. I can't remember if you'll see there's a direct consequence of this here. You can see that this sphere, he says, leaning over and pointing. The segments bit says that the big sphere has to have 256 segments, which is around the outside edge. So when I'm constructing that mesh, I have to make it a more finely detailed mesh than the smaller spheres I was using, because otherwise the outside edge looks all clunky and you can see the triangles. So there are a few places where the consequences of it being meshes means it becomes apparent and you know it's there. And then the other thing was feedback. Yeah, there's some analog feedback filters you can apply here, which are kind of interesting, which I use for doing some trippy effects. I don't really tend to do much of that. Most of the stuff that I do is done through using a physical controller. And then what I can do is I can feed the MIDI signals from that in as external values into the engine, and then I can stick those in at various points. So I can have like a knob you turn that changes how big something is, or how bright it is, or a button you push that makes something jump or move or disappear. So that tends to be how I kind of run visuals, I suppose, when I'm performing. Yeah, no variables. It's functional language. You don't get variables. Sorry.
Okay, amazing. Thank you very much, Jonathan. Round of applause.